Determine the slab thickness. A new rigid pavement is to be built on the interstate highway passing through downtown Phoenix. Average yearly precipitation of 9 inches. Traffic forecasting analysis has yielded an estimated demand of 18 million ESLs. Over the 20-year performance period. The design calls for jointed reinforced concrete pavement, GRCP, with an asphalt concrete shoulder. Shoulder without a load transfer device. The properties of the local materials available are presented below. Elastic modulus of concrete. (4,000,000). Concrete modulus of rupture. (550). Effective modulus of subgrade reaction. 120. Subgrade material exhibits poor drainage. And we have 9 inches of precipitation. Okay. Reliability of 95%. Standard deviation of 0.4. Okay. Determine the minimum slab thickness necessary to satisfy the traffic demand, round up to 1/4 of an inch. Okay. So we know standard deviation of 0.4. This is in Phoenix downtown, so it's going to be a major highway. I'm going to do 2.0 for my serviceability. My elastic modules is 4E6. My modulus of rupture is 550. My ZR is going to be from table 11.15, 95% equals minus 1.645. Drainage coefficient. So from table 12.20, we have a poor drainage, and we have 9 inches of precipitation. Okay, so I'm going to go to the range 1 to 5%. And I'm gonna stay on the lower bound. So I'm gonna assume 1, just because I know Phoenix is in the desert and there's not a lot. We're being said it's 9 inches of precipitation, so I'm gonna stay on the 1 for my drainage coefficient. And then my load transfer coefficient is going to be on table 12.19. We know it's JRCP, and it's Kite PCC. Yes, Kite PCC. So without load transfer devices. Okay. So I'm gonna stay without load transfer devices, so that's gonna be no. I'm gonna stay with my 3.6. 3.6, it's without load transfer devices. And then my effective modulus of separate reaction is 120. 120. So now I'm gonna solve for my thickness. Solver data. This is 18 million ESL. 18 e to the 6. And we're gonna solve for our thickness. This does not make sense. So I'm gonna solve again. Okay. Okay. So I'm gonna double check my numbers. Standard deviation, serviceability, modulus for my concrete, 4 million. Separate reaction, 120. Effect, concrete modulus of rupture, 550. My 95% reliability, my drainage, my modulus load transfer, my coefficient of load transfer, device, asphalt concrete shoulder. Asphalt concrete shoulder. Okay. So I'm gonna try to solve again. This should solve for 18 million. My thickness should solve for So I know the answer it gave me is wrong because it gave me an ESL my ESL should be 18 million. I have no idea why it's not working. It should be a 1.8 times 10 to the 7, and then my thickness. So I'm gonna try to do it manually, just because I'm not sure why it's not giving me the proper answer. So I'm going to get as close as I can. So 13, 14. Okay, so 13.75, 14. Okay, so my minimum thickness should be 14 inches. Yes. Yes, so my minimum thickness should be 14 inches. That way we get 1.87 times 10 to the 7, which is 18,700,000 for my ESL. So I'm just gonna double check my numbers to make sure that's the correct answer. So